We are in Chapter 9, Inferences from Two Samples. 9.1 is Two Proportions. In Sections 7.1 and 8.2, we discussed inferences regarding a single population parameter proportion. The concept used in those previous sections will be extended to include two samples. Hypothesis test is what we did last chapter, is conduct a hypothesis test of a claim, but this time it's about two population proportions. We also will go back to confidence intervals, which we saw in Chapter 7, to estimate the difference between the two population proportions. Give independent sampling methods and dependent sampling methods a star. Independent is when the individuals selected for one sample do not dictate which individuals will be selected for a second sample. And then dependent sampling, also called matched pair sampling, is when individuals are selected to be in one sample are used to determine the individuals in the second sample. And note, it's possible for individuals to be matched up against him or herself. Remember, a few things to remember here: qualitative and quantitative data, and a response variable. I'll let you guys look over those. Sampling distribution for the difference between two population proportions, independent samples. So suppose a simple random sample of size n is taken from a population where x1 of the individuals have a specific characteristic, and a simple random sample of size n2 is independently taken from a different population where x2 of individuals have a specific characteristic. The sampling distribution is p1 hat minus p2 hat, where p1 hat is x1 over n1 and p2 hat is x2 over n2, is approximately normal with, and you'll notice we have the mean and we have our standard deviation of those differences. Again, not as big of a deal for you guys with the formulas just because we do use the calculator, provided that, and we still have criteria that we need to read through and make sure that those are met before we can go through with the test. So I'll let you guys look that over on your own. The next thing says, the null hypothesis is a statement of no difference. As always, and it says, so H naught is always going to be P1 is equal to P2. They're the same. Because H naught is assumed to be true, that implies that if they're the same, if you were to subtract them, you would get 0. And we would assume that since they're the same, we can say instead of P1 and P2, we could just say that it's equal to P, and P is the population proportion. So example down here, it says determine whether the sampling is dependent or independent. Indicate whether the response variable is qualitative or quantitative. So take a second to read through those. A says a researcher wishes to determine the effects of alcohol on people's reaction time to a stimulus. She randomly divides 100 people aged 21 years of age and older into two groups. Group 1 is asked to drink a 3-ounce alcohol, while Group 2 drinks a placebo. Both drinks taste the same, so the individuals in the study don't know which group they belong to. 30 minutes after consuming the drink, the subjects in each group perform a series of tests meant to measure reaction time. So since those two groups have nothing to do with one another, just because you got picked for Group 1 does not mean that someone else has to get picked for Group 2. These would be independent. And they're measuring reaction time, which you can measure numerically. So this would be quantitative. B says a political scientist wants to know how a random sample of twins over 18 years old feel about Democrats in Congress. So we are talking about twins. She obtains a random sample of 224 registered voters who are also twins and asks, do you have favorable or unfavorable rotating the opinion of Democratic Party? Each individual was asked to disclose his or her opinion about the party, and the twins' opinion were recorded. So since you're working with twins, if you ask one twin, you have to ask the other one. So that would be dependent. And they're asking about their opinions, which is not numerical. So this would be qualitative. On the next page, I'm going to give this a star. It's a hypothesis test regarding the difference between two population proportions with the TI-8384 calculator. To test hypothesis regarding two population proportions, P1 and P2, we can use the steps provided that. So here's what you would have to check to make sure that you can actually conduct the test. Step 1 is determine the null and the alternative. And if you notice, H0 is P1 is equal to P2. And your alternative is going to depend on if it's a two-tailed, left-tailed, or right-tailed test. Select alpha, which again is usually given to you. And then trying on your calculator to make sure you understand how your calculator works. Stat, test, for me it was number 6, which is 2 prop z test. You need to enter in x1, n1, x2, n2. Select the appropriate relationship between P1 and P2. Calculate and then enter. You're going to get 2 output values that are important to us. One is z, which is our test statistic, and one is p, which is our p-value. And then going through our test, it says if p-value is less than alpha, we reject H0, and then state our conclusion. So we can also consider a confidence interval estimator of the difference between population proportions P1 minus P2. If the confidence interval estimate of P1 minus P2 does not include 0, and we're looking at does not include 0 and 0 because the difference, if they're the same, would be 0. We have evidence suggests that P1 and P2 have different values. Consequently, a conclusion based on confidence intervals might be different than a conclusion with a hypothesis test. Confidence intervals are always needed to be set up as two-tailed tests, so give that a few stars. A confidence interval always has a middle, and then the extreme values are on those tails. So to conduct a test using confidence intervals, we need to set up a confidence interval, and then here's the 2 things that we definitely need to know. If 0 is in the confidence interval, then we do not reject the null hypothesis. And if 0 is not in the confidence interval, then we reject the null hypothesis. So steps for doing this are right below. Constructing a confidence interval for the differences between two population proportions, independent samples with a TI-83 or 84 calculator. Again, you need to check that you can actually perform the test. And then you're going to stats, test, 2 prop z int. Int because we're dealing with an interval. x1, n1, x2, n2 need to be entered. Enter the confidence level. The calculator is going to give your lower bound and your upper bound. Then you need to interpret your results. So interpreting this time is, since we're doing a test, you would have to ask yourself, is 0 in that interval or is 0 not in that interval?